Welcome back to my channel.
Bing! I don't think Carly was ready that time. I snuck up on her. Okay, so we have, if you're a distance learner, we're doing page 72, and you might want to take this page 72 out of your notebook, or you can print the page off. I'll attach it to the module. So we've been solving special equations, and now all of a sudden we're going to start talking about graphs and inverse graphs. Well, the reason that we're going to do that is because on page 73, we're going to solve equations for the inverse of a function, but before we do that, we need to understand what an inverse is. So we're starting on page 72, and if you're in class, you're writing on the sheet of paper that I brought you. So the inverse of a function is created by reflecting the graph across the line y equals x. Ugh, blech. That doesn't even really make sense right now. So an inverse is what happens when we reflect a graph across y equals x. So let's remind ourselves what it would mean to reflect. If we reflected this parabola over the x-axis, he would look like a frowny face instead of a smiley face. That sounds vaguely familiar, right? Yes, we just flip him upside down. That is an example of reflecting him. So I have here the function that is graphed as this parabola. It's this one right here. 1/2 x squared plus 1. So what we did was we took a normal parabola and we made him a little bit wider and then shifted him up by 1. We are going to see what his inverse looks like. So I'm going to give you some points. The first point is 0, 1. The second point is -4, 9. And the third point is 2, 3. So these are all points on this parabola. So 0, 1 is the vertex. -4, 9 is this guy all the way up here. 2, 3 is this guy here. So I just pulled some points off of the parabola for us. Well, an inverse, in order to graph the inverse, we just switch these two values. We don't change the signs or anything else. We just switch them. So instead of having 0, 1, we're going to have 1, 0. And instead of having -4, 9, we're going to have 9, -4. And then instead of 2, 3, we're going to have 3, 2. So all we do is switch the x and y value. We just switch. So it's going to ask you, your quiz is going to ask you a question like, what is the inverse of a function? And then it's going to give you all these fancy things like, it's the negative reciprocal of the function. It's nothing fancy. It is literally just switching your x and your y. So if you see the word reciprocal or they're telling you to change signs, that's a no. So now let's graph these points. So we have a point at 1, 0, so that's 1 to the right, and then we stay there. Then we have a point at 9, so we're going to go to the right 9 and then down -4. Then we have 3, so we're going to go to the right 3 and up 2. And this starts the graph of the inverse. So one of the properties of a parabola is that they're symmetric, so we can mirror these points. We can put a point 2 below the x-axis if we have one 2 above. And then on this one, we have one 4 below, so we can put 1, 4 above. And can you guys see the parabola now? So let me sketch it for you. The inverse of that parabola looks like this. Can you guys see it? Yeah? So I'm going to darken that up. I sketched it out with my pencil, and then I just made it a little bit darker with my pen. So now let's go back up to this crazy definition. The inverse is what you get when you reflect the graph across the line y equals x. So I'm going to highlight that line. This line is the y equals x line. When you reflect, essentially what you're doing is folding the graph on that line. So if I literally fold my paper on the y equals x line and I hold it up to the light, you will see that your graph, the two parabolas match up. This graph and the graph we drew are right on top of each other. Can you guys see what I'm saying? If you're having a hard time seeing, use your pencil to darken up your parabola, and then it becomes much easier to see. Yeah, my parabola looks good. Can you guys see it on yours? I don't have a light, so it's harder for me. Oh, yeah. So that's what it means to find the inverse of a graph. It's literally like you are folding the graph on this line, and what you see in this area is where the new graph is at. Is that making a little bit of sense? What's happening? Okay, so the biggest takeaway so far is you switch the x and y values, and an easier way to think about the reflection, this is not accurate, but similar to what's happening. If you want to know what that graph looks like, think about taking your graph and just rotating it down one. So that's not quite exactly what happens, but you can get an idea of what the graph would look like if you thought about just turning it on its side. Is that making a little bit of sense? Are you sure? Okay, so we're going to do something similar with these graphs. So I'll give you some points. I will give you some points, and you are going to switch them and then graph them. So your original function is this guy. If you have markers or highlighters, it's a little bit easier if you darken that guy up. And if you want to, you could put in the y equals x line. So when we reflect this, he's going to look weird. Like if I get a preview of what he's going to look like, that guy's going to be kind of weird. So we're reflecting him. So what it's going to look similar to is if we took this graph and just rotated it down like this. So instead of a vertical line looking thingy, he's going to be a horizontal looking thingy. Okay? Yeah? Okay, good. Okay, so your points are -1, -3. So that's not right. Yes, it is. That's this guy right here. -1, -3 is that guy right there. Then 0, -2, that's the vertex. That's where it like flattens out a little bit. And then 1.5, comma 2. So that's this guy right here. It's that guy. Okay, so you flip the points. You switch them. You guys switch the points. Okay, let's see if we can figure out what this guy looks like. We have a point at -3, -1. Okay. At -2, 0. Nope, that's backward. So to the left 2 and then stay. And then 2 and 1.5. That doesn't really help us see the graph. So let me help you. This guy looks like this. And the reason that I know how to do these is because I have folded the paper a lot and held it up to the light. So I have seen a bunch of times what it looks like if we take this graph and fold it on the y=x line. If you did that, he really would look like this horizontal squiggly line. Once again, notice that it's similar to taking your graph and just turning it on its side. It's not exactly like that, but it's similar enough to give you an idea of what the graph would look like. Are you guys feeling kind of okay? Okay, so then our last one is this straight line. Well, if we've been thinking about it as just kind of turning it on its side, if I take this horizontal line and turn it on its side, what kind of a line does it turn into? Vertical. So we just got to figure out where he's at. So some points that you could use are -2, -4, 0, -4, and 7, -4. So this one's a little bit easier. Let's see if you guys can do this one without me. So see if you can get the vertical line in the right spot. I'll come walk through just to see. At least switch your points. Good. Let's go about 30-ish more seconds. No. Fine. You're welcome. When you guys need to go, you can just get up and go. I don't really get mad about stuff like that. Roughly 15. About 5. Okay, I have a vertical line going through x is -4. So if you flip these, no matter what your y value is, your x is always -4. How'd you guys do? Did you do okay? If you fold this on the y equals x, and you hold it up to the light, you can see that you're going to get a vertical line. Like this, like a so. Okay, so this is the basics of what an inverse function is. Essentially, it looks like you take your graph and tip it on its side. For each one of these examples, I think you guys can see the similarity. This one's the weirdest one because you gotta like tip him this way. So the one other thing about the graph that they're gonna want you to address is whether or not it is truly a function. So to determine if the graph is a function, you use the pencil test. Does that sound vaguely familiar to anyone? No. You use the pencil test. So these graphs are the original function, and these graphs are the inverses. And you're going to get one question on your quiz that has to do with this specific part of the lesson. So, to determine if something is a function, if you are looking at the original one, you use the vertical line test. So, vertical, just kidding. I like. You use the horizontal line test. If you are looking at the inverse, you use the vertical line test. So if you look at the original, you use a horizontal line. If you look at the inverse, you use a vertical line. So it will be a function if it only passes through your pencil at one place. So this dark parabola is my original. If I hold my pencil up to the graph, you can see that he crosses through in two places. So this is not a function. This guy is not a function. The pencil test means if you held a pencil up to it, it's a function only if it crosses through at one place in the pencil. So if you're looking at the original, you hold your pencil like this. If all they give you is the inverse, you hold your pencil like this. And in both cases, it's not a function because it passes through at two spots. Is this making a little bit of sense? Yes, no? Yeah. So on this one, if I do the horizontal test for the original, at no point does this pass through two places on my pencil. I mean, right here, it's looking a little bit weird, but really, this one only passes through once. So if I did it to this one vertically, it is a function because it never passes through at two places. This one is the most confusing one. So this one is a function. This guy is a function. Well, on this one, he's definitely not a function because he passes through all places in the pencil. You do a horizontal on the left or a vertical on the right. Either one, this guy is not a function. Okay, let me make that slightly clearer for you. You have one question that asks you, which one do you look at horizontally and which one do you look at vertically? So if you miss that question, your quiz will still be fine. But it's easier to just do it like this. So if I gave you this graph, in your brain, just think about taking this and flipping it on its side. So he would look something like this. And just use this pencil test. Is that guy a function? No, definitely not. So I wouldn't even really think about this horizontal business except for that one question. Everything I would just, in my mind, turn the graph and then hold my pencil up to down. Okay, let me give you several graphs. I'm just going to make them up, and in your brain, you turn them. So let me give you like the dumbest one. This is a function. If I, in my brain, envision it turning on its side, is he still a function? Yes. This guy. This is an absolute value function. If I turn it on its side, is he still a function? No, because he passes through too many spots. What about this? Is a function. This W is a function. But if I reflect it, is it still a function? No. He passes through a bunch of places. Is this making a little bit of sense? Yeah. You're sure? Okay. That is the first part of this lesson. So I'm going to stop our recording for the kids at home.